More than 13 billion years ago, the universe looked nothing like it does today. There were no galaxies lighting the darkness, no stars burning in the sky, and no planets orbiting distant suns. After the Big Bang, the universe expanded rapidly and gradually cooled, leaving behind a vast cosmic landscape filled mostly with hydrogen and helium gas. For a long time, the universe existed in a mysterious era known as the Cosmic Dark Ages. During this period, there were no stars to produce light. Space was filled with enormous clouds of gas, slowly drifting through the expanding universe. Although the universe appeared calm and empty, gravity was quietly at work. Tiny fluctuations in density left over from the Big Bang meant that some regions of space contained slightly more matter than others. Over millions of years, gravity amplified these differences. Regions with slightly higher densities began pulling in more gas from their surroundings. Slowly, these regions grew larger and denser. Vast clouds of hydrogen gas began collapsing under their own gravity, forming enormous cosmic structures. As these gas clouds collapsed, the pressure and temperature deep inside them began to rise dramatically. Eventually, the centers of these collapsing clouds became hot and dense enough for nuclear fusion to begin. Hydrogen atoms fused together to form helium, releasing an enormous amount of energy in the process. When this happened, the first stars in the universe were born. Astronomers refer to these ancient objects as population 3 stars. These stars were very different from the stars we see today. Modern stars contain many chemical elements, including carbon, oxygen, silicon, and iron. But when the first stars formed, those elements did not yet exist. The only materials available were hydrogen, helium, and tiny traces of lithium produced during the first minutes after the Big Bang. Because the early universe lacked heavier elements, the formation of the first stars followed a very different path. Without heavy elements to help gas clouds cool efficiently, collapsing clouds tended to form extremely massive stars. Scientists believe many of the first stars were far larger than the Sun. Some may have been 50, 100, or even several hundred times more massive than our Sun. These enormous stars burned incredibly hot and bright. Massive stars consume their nuclear fuel very quickly. While a star like the Sun can shine for around 10 billion years, the first stars likely lived only a few million years. Yet during their short lifetimes, they produced enormous amounts of radiation and energy. When the first stars ignited, the darkness of the universe began to fade. This moment is known as the cosmic dawn. For the first time since the Big Bang, light spread to the universe again. These early stars transformed the universe in profound ways. Their intense radiation began illuminating the surrounding gas clouds, and the powerful energy released from their cores began shaping the evolution of the cosmos. Inside their cores, nuclear fusion created elements that had never existed before. Hydrogen fused into helium. Helium fused into carbon, and in the most massive stars, even heavier elements began to form. These new elements would eventually become the building blocks of planets, atmospheres, oceans, and life itself. The lives of the first stars were short, but incredibly dramatic. Because of their enormous mass, they burned through their nuclear fuel extremely quickly. After only a few million years, many of them reached the end of their lives in some of the most powerful explosions in the universe. These explosions are known as supernovae. When a massive star explodes as a supernova, it releases an extraordinary amount of energy and blasts its outer layers into space at tremendous speeds. These explosions scattered the newly formed heavy elements across surrounding regions of space. Elements such as carbon, oxygen, magnesium, silicon, and iron were thrown outward into surrounding gas clouds. This process fundamentally changed the chemical composition of the universe. Before the first stars lived and died, the universe contained only the simplest elements. After these early supernova explosions, the surrounding gas became enriched with heavier elements. These elements allowed future generations of stars to form in different ways. Gas clouds containing heavier elements could cool more efficiently as they collapsed, allowing smaller stars to form. Some of these later stars had lifetimes much longer than the first stars. Many of the stars that exist in the Milky Way today were born from gas enriched by earlier generations of stars. Some of the oldest stars still shining in our galaxy may contain clues about the earliest cosmic history. By studying the chemical composition of these ancient stars, astronomers can learn about the processes that occurred during the earliest periods of star formation. The first stars also helped reshape the structure of the universe itself. Their powerful ultraviolet radiation began ionizing surrounding hydrogen gas. Ionization occurs when radiation strips electrons away from atoms, transforming neutral gas into charged plasma. This process, known as cosmic reionization, marked the end of the cosmic dark ages. As more stars formed across the universe, their combined radiation gradually transformed the cosmic environment. The universe slowly transitioned from a dark, simple state into a universe filled with glowing galaxies and complex structures. Gravity continued pulling matter together, forming the first galaxies from vast collections of stars, gas, and dark matter. Within these early galaxies, new generations of stars formed continuously for billions of years. These processes gradually built the cosmic structures we observe today. Even though the first stars themselves disappeared billions of years ago, their influence remains everywhere. Every atom of carbon in our bodies was created inside stars. Every atom of oxygen we breathe was forged in stellar nuclear reactions long before the sun was born. In this sense, the first stars were the cosmic ancestors of all the matter that makes up planets, oceans, and living organisms today. Modern telescopes are now searching for the earliest galaxies where the first stars once formed. Instruments such as the James Webb Space Telescope are capable of observing extremely distant galaxies whose light has traveled across the universe for billions of years. By studying these ancient galaxies, astronomers hope to better understand how the first stars formed and how they transformed the early universe. Each new observation provides clues about the moment when the first cosmic lights ignited, ending the dark ages of the universe, and beginning the long story of galaxies, planets, and life itself.